Welcome to homework.
We're going to start with what we know in this problem. We know that the mean systolic blood pressure of normal adults is 120 millimeters of mercury, and we know that the standard deviation is 5.6. We also know that we're going to assume normal distribution. So again, we're going to use our bell-shaped curve. Part A. If an individual is selected, so only one individual is selected, we want the probability that that individual's systolic blood pressure is between 120 and 121.8. So we're going to start by placing the 120, the mean, on our bell. And we want to be between 120 and 121.8. So we will need our z-score for both. Because 120 is right at the peak of the bell, we know that 120 would correspond with a z-score of 0. And to calculate the z-score for 128, we'll do 121.8 minus 120 divided by the standard deviation, which was 5.6. And we will get a z-score of 0.32. So when we talk about the x value between 120 and 121.8, we're also talking about the z value being between 0 and 0.32. So we're going to solve that by changing this into its equivalent subtraction problem. So the probability that z is less than 3.2 minus the probability that z is less than 0. We'll use our standard normal table from the back of your textbook, and we find the probability that z is less than 3.2 is 0.6255. We know that the probability that z is less than 0 is 0.5000 because that is half the bell. So therefore, we get a value of 0.1255. So the probability of us selecting an individual with a pressure between 120 and 121.8 will be 0.1255. Now let's go on to part B. We're just going to scoot this up a little bit. And for part B, it's asking us, now we're going to select a sample of 30. So let's still talk about what the population was. The population had a mean systolic blood pressure of 120 with a standard deviation of 5.6. And now we want to talk about the sample. And the sample size in this case, we're going to select 30 adults at random. So we now need the average of the sample means, and we need the standard deviation of the sample means. And the average of the sample means is the same as the average of the population, which is 120. And the standard deviation of the sample means is equal to the standard deviation of the population divided by the square root of n. So in this case, it would be 5.6 divided by the square root of 30. So again, we're going to set up our bell-shaped curve. we're going to put the average in the center, and the average was 120. And let's look at the problem that we are trying to solve. And the problem we're trying to solve is if a sample of 30 adults is selected at random, what's the probability that the sample mean is between 120? So this time we're going to have an X bar in our statement and 121.8. So we're going to need the 121.8 on our bell, and we want to be an average of the 30 adults to be between 120 and 121.8. So again, we are going to need to calculate the z-scores for each of those. And this time the formula is going to change slightly. It's going to be x bar minus mu sub x bar over sigma sub x bar. So we have an average of 121.8 minus 120 divided by 5.6 over the square root of 30. So the z-score turns out to be 1.76. Again, we know that the z-score associated with 120 is 0 because it's at the peak of the bell. And if you think about the fact that being between 120 and 121.8 is the same as when our z-score is between 0 and 1.76. So we could rewrite that as the probability that z is less than 1.76 minus the probability that z is less than 0. And we would rely on our standard normal table, and we would find that the probability that z is less than 1.76 is 0.9608. And the probability of z being less than 0 is 0.5000, and we get an answer of 0.4608. So for part B, the question was, what's the probability that when we select 30 people at random, their blood pressure is between 120 and 121.8, and I should say their average is between 120 and 121.8, and that probability would be 0.4608. And then finally, for part C, part C is asking us, why is the answer to part A so much smaller than part B? So let's just recap what the part A and the part B were. In part A, we were talking about an individual person's blood pressure, and we had an answer of 0.1255. And in part B, we were talking about taking a sample of 30 adults and their average blood pressure being between 120 and 121.8, and we found it to be 0.4608. So the question is saying, why is this one so much smaller? And the reason would be that a sample mean will be closer to the true mean than an individual value. So the true mean is more likely to be the 0.4608.